Okay, so I uploaded to web courses an example called dynamic memory.c. And so it has examples of the different functions that were used for dynamic memory allocation. I got an email from somebody who tried to do this to the 330 lab on Wednesday, and he was an OSHA. I'm sorry about that. I will get in contact with them and reinforce the importance of their attendance to those labs, seeing as they're the ones that are supposed to be there to help you. Okay. So as promised, we're going to talk about memory management today. Don't forget Jonathan's SI session. Today is Friday, so he has one in between the 9:30 class and 11:30 class. And then also Kyle's session. And your TAs, labs, in theory, if they show up. That's awesome. I'll deal with it. All right, so memory management. So in Intro to C, they probably, we did character arrays and stuff like that. That's static memory management. Because you already know what the size of that array is going to be. So you just define it like that. And so, this is just an example where you just define an array of 100 characters because you know that's how much memory you need. But in reality, in the real world, 9 times out of 10, we have no idea how much memory we need. And so here comes dynamic memory management. And so really, when you deal with different types of data and stuff like that, you have no idea what it's going to be. It's like the data file I gave you for assignment 1. You have no idea how much data is going to be in there, right? So, a lot of times, sometimes you want to store like a detailed description about something. So what we end up doing and how we get around that is we just define a pointer to a character without defining the actual size, like the character array. And so what we do then, we later on, when we're ready to use that variable, that's when we do the memory allocation on it. So in the C programming language, they give us functions for that. And there are 4 functions that help us deal with dynamic memory allocation. And they're actually part of your standard lib header file. And so what this does is it gives you control over the size of your data whenever you're using it. So in the functions, the first one is calc. This is just in alphabetical order. That's the rhyme and reason, okay? Calc. So this is a function that allocates an array of num elements. Num is the size there at the beginning, and which the size of each one of those elements is decided. So if it's a integer, then it's so many bytes. If it's a character, so many bytes. So that's the size it's going to do. Now, when you're done using memory, it's very good programming practice to free that up. And so that's what the free is for. And you just use the address of whatever that variable is. So you use the variable name, and that's how you pass it to free the memory. And then we have our malloc. The malloc is the one that you will see most commonly used. But the important thing about malloc is that data is uninitialized, and which is opposite of calc. And I have a slide here that talks about why you use one over the other. And then finally, we have the reallocate. You need to change the size of it. For some reason, you find out you don't have enough memory allocated, and so we're just going to change it to a different value. So this is just my output from the code using my malloc. So if you go and look at the code here, you see my malloc example. I have 2 variables. I do my explicit character array, so we know how much memory we need in this case. But what I don't know is the on line 9. So I have no idea how much memory I need. So I'm just going to create a character pointer, and it's going to be at some location in memory. And then the second one is just the declaring my variables I'm going to use for telling, and then I do my variables I'm going to use for my reallocate. These guys just have separate ways of doing it. All right, so the first one here you see with the malloc, where I'm going to do a string copy. So I have no idea how much data this is. So I just use the string copy, and if you remember, the string copy is one of the functions as part of your string header file. Definitely go look up all the wonderful functions that are available to us in the string header file. They make your life so much easier instead of having to directly manipulate character by character. So here, I have no idea how much memory I need, so I just go ahead and use my m name, and I do a string copy into that guy. Okay, this one I do know. I'm having a rough day. Some days it just doesn't work out. Okay, so here I have up to 100 characters available, but this I'm only copying in this right here. Okay, here I have no idea how much data I'm going to put into my description. No clue whatsoever. So what I do is I call malloc, and then I say, well, let's try 200 data enough. So what the malloc is doing is allocating an array of some number of bytes, in this case 200, times the size of my character. So we just do the size of to determine how big that data variable can be. And it dynamically allocates the number, but it leaves it uninitialized. It is uninitialized. That means the data is not initialized at all. Okay, so it's you have the memory, but it's not initialized. Yes. No.
Okay. Well, why are we multiplying the size of the character by 200 inside the malloc?
Because that's how much memory we need. So we want up to 200 characters available to us. So you say the 200, however many you want, times the data type. If I wanted all integer data, it's just the data type. Because remember we talked about our data types have different sizes, depending upon your programming language. Basically, the general rule of thumb is that whatever the data size is in C and C++ and Java, it's doubled. Okay? So you just have to make sure that you have enough memory, and you want it based on the data that you're going to store in there. So, 200 integers is not the same amount of data as 200 characters, because they take up different amounts.
Okay, so it's like kind of a conversion kind of thing.
Yes. Good? Okay. Yes.
Can you put in there a user-defined variable? Like if for the user can they write in 200 and you set it to n, so that it can adjust based off of what the user needs?
Yes. This is just a simple example, just to provide a voice track on how memory allocation works. But it's not limited to a data type. It's any data type that's valid. So if a user creates their own data type, like maybe they do a struct, we would allocate the memory for the struct. Like in our linked list example, that takes up more memory than your character, right? So that's why we do the size up. Does that answer your question?
Well, I was thinking more of like instead of the 200, could you put n and then have the user define what n is?
Where would they define that?
Like if you did a scanf function or something.
Oh yeah, definitely. This is just a hard-coded example. I mean, usually there would be some other type of way to determine how much we need. But this is just a hard-coded example to give you some type of an example of how the memory allocation works. Did that answer your question?
Yeah.
Okay. Anyone else? Yes.
Whenever you do a funky shortcut on your IDE, can you please just shout out what that shortcut was? Like you did a thing where it copied the line that you were currently on and then put it right below it. It would have been nice to know what that shortcut was.
Oh, it's just Control C, Control V.
Oh.
Copy paste.
Okay,
I'm not that magical. No, it's just Control C, Control V. But yes, thank you. If I do that, I will. Sure.
just want to make sure I got this right. You had an inferior size to the 600 volt.
And if it's got 4 bytes, so it would be 2,180.
Okay, yeah. I know this. I'll give you an extra 200.
No. There's 200 of them. So we need to make sure we have enough memory to store all 200 of them.
Okay.
Okay.
Size 3, not size, ints that, like, there's some type ints that's like, what's like number 3, like number 1,000. You allocate the same memory, like so many times the size of ints, you get the same amount of bytes.
Yeah, because it is takes up 4 bytes. That would be the top. In C, is on top. Java is because Java has the Java version of key environment. So, I think you have a slide. Oh, I have the video memory. And I can't remember. Okay. Quick. But I don't know. Sorry. Did I answer your question?
Could you set up if you didn't know, like if you wanted to set a maximum size for the ints or the description, and you wanted to make it in as on you have like a temporary variable that holds the description and then finds the calibrate how the size of that one.
So that's what we allocated.
Reallocate.
Yeah, so we have that later.
Okay.
If you need to, let's say you allocated 1,000 bytes and you're like, oh crap, I don't have enough, so like, yeah, using the same variable, but you're increasing size. Or you can decrease it if you have too much and you want to free up. I mean, again, in today's computers, it's not that big of a deal, but it's just good programming practice at this point to make sure that you don't take up too much if you don't need it. Kind of like, I can only eat 5 apples, but I'm gonna hog all of them. You know, I can only eat 5. Rude.
So that's when the program take up memory, does it take up the tender memory, the RAM,
Yes.
the RAM?
It's runtime memory. It's runtime memory, not physical memory on hard drive.
So basically it's taking the RAM.
Yeah. Do I what? Oh, yeah.
Just go off topic real quick. What's its default?
Garbage. Just garbage. Yeah.
That makes sense.
No, it's just, I actually have output piece of garbage that I output. What I freed up to memory, and I try to reference that later.
But
It's
it's
just
not
garbage.
ever like initialized to around.
With mallet? No. Well, no, you're saying is it a specific address or a
I think
specific
when
value?
you like when you declare like our internet description, is that
Just
address?
garbage. There's just nothing right now. Not until you actually physically do the mallet, it's just garbage. Okay, answer your question? This one. All right. So my example file has all of this. This comes out all at once. So I just did one by one. So in my first example, I used the name as my character array of 100, whereas in my description, I just put in this indeterminate length string. And so in order to get my the amount of memory I wanted, here I just did a malloc and went, hey, this is what I'm going to do. Put this guy back. That was a copy of Control-C, Control-V.
Thank you.
I respond. You ask me to do stuff, I do it. You're not going to get that from anywhere else. All right. So what happens is when you try to do that malloc, you want to make sure that it actually works. Because if it didn't work, what's the point of moving on? Because you don't have the memory for whatever you're trying to do. So you always want to check to make sure it didn't come back null, that you're not out of memory. Otherwise, what I'm doing here is I'm using my string copy function and I'm just putting some explicit string and copying it into that variable. So that's what the malloc is doing for us. And here I just output what I did. So we also have the option to do calloc. So calloc is different than malloc. Malloc, when it grabs that memory, it's still garbage until you put something in it. There's nothing explicit. There's no explicit anything stored in there. Whereas calloc actually comes in and initializes that data and it's zero filled. So what's kind of interesting is here, so that data is zero filled when we first have it. And so if I don't even have anything in there yet, so I'm going to do a control C and a control V to show you what it looks like before I even do my string copy. Okay, so up here you can see, here's my calloc. And you see my description here. This is the one where I did the calloc, and all I did was initialize it. So it doesn't come back as garbage in this case. You see that? There's actually something in it. It's cleared out, just like all zeros. Whereas if we did that up here, you could potentially, not guarantee, but you could potentially get garbage on this one. So before I do my string copy on the malloc, let's see what it looks like. See that garbage right there? So that's the difference between calloc and malloc. So with a calloc, it came back, just an empty string, it's nothing there. Because calloc initializes the memory to all 0 bytes when you do the actual calloc memory allocation. The malloc does not. So you see, you end up getting garbage. You see the difference between malloc and calloc? So that's the only difference between the two. Now, why would we use one over the other? So again, calloc will zero initialize its buffer. So you use calloc when you want to allocate a block of memory and you want it to be initialized. Malloc, however, leaves the memory uninitialized and it doesn't even touch the contents of that allocated block of memory. So you see when I printed it out, when I did my malloc for my description and I didn't set it to anything, when I outputted it, it was just a bunch of garbage, right? And so why would you use one over the other? For some reason, programmers prefer to not use calloc. They actually like malloc. So what they do is they initialize their array, their pointer, they initialize their pointer, they create their malloc, and then they actually call this function called memset, and then go back and zero initialize data. I don't know why. We are strange creatures. I don't know. I don't know. I cannot explain it. I would have to do a poll and say, do a survey and find out why. Why don't you just use calloc? Why are you writing 2 lines of code and do the same thing you do in 1 line of code? Yeah.
I'm just saying, theoretically, would your program work if you did not initialize it?
Well, it does. I mean, as long as you
You
start.
just might get garbage values.
Yeah, you're going to get garbage. Yeah.
But if you don't screw something up, then it should still work.
It does. Yeah. I don't know. Programmers are a strange breed. We do whatever we do for whatever reason. So there's functional data, and that is that. It just initializes the data and the memory is part of the standard library. Yeah. No? I don't know why you do this. It's just arbitrary. Okay? So it's just one of those things. I don't have a good answer why we do malloc and then memset instead of just using the calloc when calloc does that for you. Okay, any other questions? All right. So this is just my output example that separates just the calloc itself. So releasing memory. This is one of those best practices. You really should do this and free up that memory. Back in the day when I started programming, memory allocation was a really big deal. You didn't have that much. Now it's kind of like, whatever. But it is a good practice to make sure that you manage that, because actually C and C++ programmers and those languages are very specific about the memory management, whereas like with Java and C#, they just do some auto garbage collection for you. So when you release the memory, there's two different ways it gets released. If you end your application, by default the memory is released. The operating system just lets it go. Otherwise, in your application while it's still running, if you don't need that memory anymore, it's really good practices to call this function free. So this is just some output from my application. I just commented some things out and all that. So you see here I have my malloc, and then I have a free. And you see that, so what I did was on my description, because my description is my pointer guy. So on my description, I freed up that memory, and then I printed it out again so you can see what it looks like after that memory's been freed up, and you see you just get garbage from it, right? So just like before I actually initialized the data up here in this example. So here I did my memory allocation, and I printed out just so you can see what's in it, and I showed you that it's just garbage. But then after I actually run the string copy and copy the data that I want into my variable, then you can see it comes back the way I want it to. And again, with the calloc though, that guy, when I print him out, he comes back clean because he's zero initialized. So you don't get that garbage with the calloc. But programmers are weird. We prefer malloc, and we ignore calloc. We write an extra line of code using the memset to initialize it. Strange, strange animals. Okay, so here is where my free is at. So here I have my data. I come down here, and I free up my name, and I free up my description. All right, and then I'm going to output that again, and then I do the same thing with the memory that I use on my calloc. I'm also going to free that up, and then you can see the output. So you can see here. All right, so the first time through, this is just what my description looks like with a malloc. It's just garbage. And then here, after that, I use the malloc to the string copy function to actually copy that data into my description variable. This is an example of the calloc and outputting it, and you see it comes back clean. God forbid should we do something that makes sense. So then here you see after I free up that malloc, and again, it's just garbage, okay? It's just, there's nothing there. And then we come down here, but after I do the free on the calloc, it's still totally cool, with the exception of this guy right here. So now he's garbage because I freed up that memory, all right? And then finally we come down here to reallocate, and we'll look at the reallocate. So any questions about freeing your memory? So it's just an easy function call. You just say free, and it lets you go. Questions, concerns? Yes.
Is there any reason that the str copy function wouldn't work if you're trying to copy something from a pointer into an array?
Is it an allocated array?
It's just an array in string.
I'd have to look at the code. Off the top of my head, I didn't answer that. Yeah.
When you calloc a chunk of data memory, and so you say it takes memory and then it fills it full of like zeros or something, then in your if statement, you're still checking to see if that equals null.
That's good programming practice. You always check to see if stuff is null before you try to operate on it.
So when you establish the memory and then you fill it full of something, it still equals null though?
If the calloc fails, if there's not enough memory. So let's say back in the day we had 24 meg, right? That's all the memory we had. Or it's a 64 meg. One of the most famous things Bill Gates unfortunately is known for. Who would need more than 64 meg of memory? Look at us now. Alright, so back in the day when we had to do memory management and we really didn't care, potentially you could say, hey, I want a gajillion freaking bytes, okay? Well, the 64 meg, you don't have that many. So you can try to allocate it, but it still might fail. That makes
And
sense?
if it fails, then it's just gonna be no.
Then it's gonna be no. So even though, so what you're saying with the calc is, if this memory is available, zero fill it for me so it's cleared out so I don't get garbage. But you still gotta check to make sure it's there. Because just because you ask for it, it's like going to the bank. You have $100 in your checking account, and you say, hey, give me $200. It's gonna go, ha ha, no, okay?
Okay, alright,
None of that. If it's not there, it's not there.
alright,
No matter, you can ask, and still it's not gonna be there.
alright. One more question.
Mhm.
When you freeze something, what does it do with the data that's there?
It's gone. It's completely wiped out. Is that, you did a hard reboot on your computer. Whatever was in memory is just toast.
What's there now?
Garbage.
How to get there?
There's these little minions. It's just, ooh, that's a different class.
Okay.
I mean, it's just there. It's just memory that's there.
Okay.
Some things you just gotta accept.
Alright, we can go with that.
Yeah. It's kind of like zero is true. Anyone else? Yes.
What does the variable C name stay the same even after you free it?
That's an awesome question.
Because the C description got reset, but C name remains the
The
same.
C name is an array. An array is explicitly taking up 100.
So wouldn't freeing it clear that?
In theory, you would think it would. But it's static memory, it's not dynamic. So the freeing with static doesn't really work. Because you're not really doing that. The freeing is for dynamic. The static is saying, hey, these 100 bytes are mine. I keep it them, and you can't have them back.
And the description is just that's what you alright, makes sense.
You just said zero is true.
I know I did. So I wanted to share. See, you're keeping me honest. I like it.
There's something.
She's not going to let me lie to you guys. She's wonderful. Make you friends with her. All right. Let's talk about reality. We don't want to do that. Okay, so you can reallocate. You can increase or decrease the amount of data. So let's say back in the day we really cared about memory management because there wasn't that much, and you said, hey, give me 1,000 of these guys, give me 1,000 characters, and you realize you only need like 200. So you don't want to hog all that memory, so you would reallocate and you would like let some of it go. Or let's say, oh, I only asked for 200 characters, and now I've got this data set that's like 500. Holy crap! I need to reallocate. You don't want to have to start all over again. And so what you would do is use this reallocate function. So here you can see we have a reallocate. So initially, I'm going to say I want a mallet of 300. And then I check it, and it's going to say, no, that's not enough. So I check this guy, and I actually come back with a no. Let's just pretend. There's not enough memory. I can't do that. Trying to put more stuff in there than I have room for. So let's do it's not big enough. It's gonna fail. So they're like, oh, I need more. I need more. There's not enough power. I need more power. Okay. So down here with the reallocate, you just reuse that variable name. See here? So now I'm just changing how much memory my R description is taking up. So then how much I'm going to add to it. I'm going to add another 300 because I need more, and then we'll come down here, and then everything will be wonderful and happy, and it works. So here, you see where I got this error. It says, hey, I don't have enough memory for that. Let's try that again so that we can get more memory. So, dynamic memory management. Lots of times in the real world, we have no idea how much memory we need. So this is what we do dynamic memory management for. We have the calc and the malloc to actually do the initial, yeah.
Is it the other way around if you have too much memory reserved, you use your knowledge to,
Yeah, you can go down too. You don't have to. You can go both ways. So calc initializes it with 0. Malloc does not. For some reason, programmers like to use malloc and then the mem set to initialize the data on a row. Control things. You know, we don't want to just have days that the calc is over. You want to know for sure that we got that initialized. When you don't need that memory, we use that free. And then if you need to change how much memory you have allocated for a specific variable, then you can use the reallocate. You can either add or take away how much memory you have used. Is there any questions about memory allocation?
So losing that, like, so if we're using only to downsize how much data we need, like reallocate, just do that, like use reallocation for downsizing.
As well, yeah.
So it works the same like if you were.
It does. Just changes that.
If there's data that's extending past the new size, does it just drop? It truncates all
What
that?
ends
or-
up happening is you get what's called a buffer overrun. So it's there. So it's kind of like, let's say I initialized, heads up penny, it's my lucky day. So what happens is, it's like, here's an example. A student was telling me, he says, hey, I created this character array at size 0. And I stored 15 characters in it, and it worked. Okay. But if you try to, at some point, try to use that memory of that buffer overrun, you're going to end up with problems. So one of the things I've always said is C and C++, they let you shoot yourself in the foot, basically. It's like, here's the gun, go for it. Okay. So you can make those mistakes, and that's why you have to be careful and why we do memory allocation so that we know that we're not running into that problem. And that's why you'll see that we do the malloc and then the mem set and initialize our data and make sure there's no garbage if there was a buffer overrun. Does that make sense?
Yeah.
It is 10:08. So if people have questions about the homework assignment, so especially for those people that the TA never showed up, I have 12 minutes. This is your time. You want to talk about the linked list again, you can. Otherwise, you are free to go. Yes.